Good morning, students. Now we can solve problems based on Poisson distributions. Already in the previous video, we have solved one problem. So I start here at a second problem. A manufacturer of cotton pins knows that 5% of his product is defective. If he sells pins in boxes of 100 and guaranteed that not more than 4 pins will be defective. What is the probability that a box will fail meet his guaranteed quality? That is the question. You understood the question? Actually, a manufacturer of cotton pins knows very well 5% of his product is defective and he placed 100 pins in a box. So, 5 pins should be defective as per the statement given in the problem. And he guaranteed that not more than 4 pins will be defective. What it is the probability that a box will fail to meet his guaranteed quality? That is we need to find out. To do the problem, defining x is very important. Let x number of defective pins in a box that we can consider. P is the probability of a defective pin. So what is P here? P is here 5%. That means 5 by 100. Okay. P equal to 5%, 5 by 100, or else we can write it as 0.05. Anyway, so the number of pins in a box is 100. We can take it as n. I told you, we can convert the binomial distribution as a Poisson distribution when we need to find the mean mu lambda. That can be defined by means of multiplying n into p once we know. Now we know, so we can multiply that. So lambda it becomes 5. Okay. Let lambda x, it follows probability with the parameter lambda. So that p of x equal to x equal to e power minus lambda, lambda power x by x factorial, x takes 0, 1, 2, 3, etc. infinity. What actually we need to find out? Probability of x meets his guaranteed quality as faith. So he guaranteed that not more than 4 pins are defective. So we have to get it as more than 4 pins as defective. That is equal to 1 minus P of X less than or equal to 4. So 1 minus P of X equal to 0, 1, 2, 3, 4. When you substitute all X in this PMF and add on, we can get its answer as 0.5620. This is the answer of the question. Likewise, we can do one another problem. Third question, in a box, in a book we can do one another problem like this. In a book of 520 pages, 390 typographical errors occur. Errors. Assuming Poisson's law means Poisson distribution law. For for the number of errors per page, find the probability that a random sample of 5 pages will contain no error. So very firstly we have to find out a page will contain no error. Then we can get 5 pages will contain no error by means of a formula. You know that the probability of success P means probability of n times success is P power n. Simple formula, we can use it. Okay, now we can start its solution. Let capital X a random variable which is nothing but number of errors per page. P probability of an error in a page. Page. Then X, it follows Poisson distribution with parameter lambda. So P of X equal to X, that is equal to e power minus lambda, lambda power X by X factorial, X equal to 0, 1, 2, 3, etc. Now the things what we need we can note down. Now we can find the parameter lambda, which is very very important to proceed the problem. Lambda 390 typographical errors occurred out of 520 pages. So that 0.75 is the lambda, which is a positive quantity. Now, therefore, P of X equal to X, it can be written like this. E power minus 0.75 into 0.75 to the power X by X factorial. X takes 0, 1, 2, 3, etc. What actually we need to find? To find The probability that a random sample of 5 pages will contain no error. A random sample of 5 pages will contain no error. First, we can write down P of no error in a single page. That is equal to P of x equal to 0. You substitute in the previous formula x equal to 0. What it comes? That is equal to e power minus 0.75 anything power 0 1 by 1. Okay, so simply it comes as 0.472. Now 5 pages no error. This is P. Therefore, probability of no error 5 pages equal to 0.472 to the power 5. Answer it comes as what it comes 0.0234. That's it. Now I write one another problem. If you have a time, we can do it. Answer or else I leave it to your practice. You do. Okay, problem number 4. A car hire firm a car hire firm has 2 cars which it hires out day by day. The number of demands for a car on each day is distributed as a Poisson distribution with a mean 1.5. This problem mean is given direct. Calculate the proportion of days. Calculate the proportion of days on which some demand is refused. Refused means no car available in the farm. Okay, now we can do its answer also since we have a time. Let x number of demands for a car. X, it follows Poisson distribution with parameter lambda. It is also given directly 1.5. P of x equal to x, which is nothing but e power minus lambda, lambda power x by x factorial, x equal to 0, 1, 2, 3, etc. You understood the question? In a car form, car hire form, it has two cars, which it higher day by day the cost. The number of demands for a car on each and every day is distributed as Poisson distribution with mean 1.5. Calculate the proportion of days on which some demand is refused. Demand is refused means already we have only two cars. When both the cars went out, we can refuse the order. So we have to find out P of X greater than 2. Okay. For that, we need to get the answer. P of x equal to 0, which is nothing but both the cars, neither car is used. So P of x equal to 0, e to the power of minus 1.5, answer is 0.2231, use your calculator. Next, order is refused means P of x greater than 2, that is equal to 1 minus P of x less than or equal to 2. That is equal to 1 minus P of x equal to 0, 1. That is equal to 1 minus P of 0 e power minus 1.5, 1.5 to the power 0 by 0 factorial plus 1 means e power minus 1.5, 1.5 to the power 1 by 1 factorial plus e power minus 1.5, 1.5 power 2 by 2 factorial. When you simplify all three answer, it comes as finally 0.1913. Likewise, you can do as many problems once you get a clear idea. Thank you, students. Thank you so much. In the next video, we can see geometric distribution.